Good morning, everyone. It is truly a great honor to be opening the IESA Vision Summit 2024 with a keynote from D-Matrix. Firstly, my apologies for not being there in person. I was visiting India just a couple of months ago, meeting with my team in Bangalore and cheering the Indian cricket team on their World Cup campaign. I do plan to be in Bangalore in the near future and hope to meet with all of you. For today's keynote, I plan to cover the following topics. Please allow me to share my slides. Firstly, I would like to talk about the great excitement around generative AI that is gripping the whole world and the role of India in this global phenomenon. After that, I would like to talk a little bit about some of the underlying problems that prevent generative AI from being available to everyone. One of the core problems is around the compute that is available to run generative AI. At D-Matrix, we are solving a next-gen compute problem that will allow generative AI to be commercially viable for everyone. So I will touch upon the D-Matrix solution, specifically around a digital in-memory computing platform that D-Matrix has built and pioneered that will allow the widespread deployment of generative AI. But first, let's talk about the exciting world of generative AI. And it is truly encouraging to see the Indian government under the leadership of Prime Minister Modi to have embraced AI as a kinetic enabler to digitize the Indian economy. Generative AI has the potential of adding $1.5 trillion to the Indian GDP by 2030. This is a staggering amount of productivity gain that can be made available by AI. A lot of the Indian corporate business leaders are also embracing AI very rapidly. And it is great to see that CDAC has a supercomputer, an AI supercomputer called Eravat, that has ranked in the top 75 of the top 500 supercomputing list. So clearly, India has already started making forays into the world of AI compute. I'd also like to touch upon Project Bhashini. This is a very amazing tool that will allow breaking down of language barriers in a country like India, which has over 122 languages and close to 1,500 plus dialects. Today, most of the internet content is dominated by English, followed by Chinese. With Project Bhashini, this content on the internet will be available in various dialects and languages to everyone in India, and 53% more users, 53% of users in India that do not use the internet today will now be able to access all the content on the internet. Bhashini is truly an open source repository of datasets, models, and tools. Anyone can contribute to this repository. And this open source democratic approach of building a language tool using AI is indeed what India needs to break barriers and to make the internet available across the country. Next, I would like to touch upon the exploding world of generative AI globally. Generative AI is a tool which allows the user to prompt AI and ask it to generate very specific content. And this content can be software programs, it can be music, it can be movies, videos. All mediums are covered: language, text, speech, video, images, etc. Clearly, this is a very exciting development. Post ChatGPT, which was the first generative AI tool that was very, very popular across the globe, various other companies have now stepped up to build tools and applications around generative AI. And clearly, there is a lot of emphasis on deploying this generative AI across the world, which is called inference. Training is the part where you train the model and make it capable enough. Inference is the part where you take a trained model with all its abilities and deploy it and make it available to everyone. D-Matrix is focused on the inference part, the deployment part, where we help efficiently deploy these models and make them generally available to everyone. However, there are some problems before generative AI is widely available. Today, demand way outstrips supply. As you might have seen with the announcement of ChatGPT, ChatGPT became immensely popular and there was at least 1 million users that started using that tool within the first 5 days of its deployment. Very quickly, the word spread and there was 100 million users in a span of 2 months. What that meant was that the underlying compute, which was running on GPUs or graphical processing units, fell way too short. OpenAI, the company that launched ChatGPT, had to put a cap on the number of users that could use ChatGPT. Even today, almost 1.5 years later, there are companies that are building tools but putting caps on the availability of these generative AI tools because there are not enough GPUs available to run these tools and applications. GPUs or graphical processing units were built 30+ years ago and are being used today to run and deploy AI. These are not the most efficient compute engines to run AI. And that is the reason we have a shortage of GPUs across the planet, because these GPUs are very costly. Companies require anywhere between 10,000 to 30,000, sometimes even hundreds of thousands of GPUs to deploy AI and run AI and even train AI. And this can be a very costly affair. In fact, it is available to a very select few companies across the world. So cost is clearly a big problem and a challenge when it comes to making AI generally available. Power is another issue. Again, as I stated earlier, GPUs were built almost 30 years ago, and they are not the most efficient compute engines. If we continue to run generative AI at the pace at which it is popular on GPUs, we will be consuming more power than the entire human workforce by the year 2025. Clearly, this is an unsustainable trajectory. The other challenge is the size of the AI models. The models are getting larger as time goes on. That means they require a lot more compute and they cost a lot more. We are on a trajectory that if we don't do something differently or change the trajectory, we will be spending more than the entire GDP of the United States to run AI compute by the year 2030. Clearly, this is not sustainable, and bigger is not necessarily better. So we have to find an alternate way. So I'm here to talk about what D-Matrix is doing to help solve this problem. D-Matrix has come up with a fundamentally new computing paradigm, which we call digital in-memory compute. This paradigm breaks through the AI barrier. The AI barrier today is the barrier between compute and memory, where data needs to be fetched from memory, used by the compute in a repetitive and parallel fashion, and then sent back to memory. A lot of energy, time are consumed in the process of doing these repetitive and parallel calculations. Traditional architectures like CPUs, GPUs, FPGAs that are shown to the left-hand side of this slide use an architecture called the von Neumann architecture, which are not able to address the AI barrier problem. D-Matrix has come up with a solution which is based on in-memory compute that breaks through this AI barrier. At the core of the engine, as shown on the right-hand side, is a compute engine that is embedded inside digital memory. What you see on the left-hand side is a more traditional computing engine. And the compute engine fetches data from memory in a repetitive and parallel fashion across a low bandwidth interface typically. And lots of data needs to be fetched from memory for this repetitive and parallel compute, which means these architectures end up spending a lot of energy, a lot of time, and obviously that impacts the amount of compute that can be done. In the case of the architecture on the right, as pioneered by D-Matrix, we have a compute engine that is embedded inside the memory itself. So this is the same memory that holds all the data for the AI models, and the computation is happening inside the memory. We essentially went down to the level of a memory bit cell and converted it from a 6-transistor cell, which is a typical SRAM cell, and augmented it with more transistors to convert it into a compute and storage cell. So essentially, we took a memory that was meant to store data and converted that into a computer. This is the core innovation around the D-Matrix architecture. And this is what allows immense throughput, low latency, and extremely low energy, especially when it comes to the inference part of AI compute. And this is the part where AI models again get deployed, and the cost economics of running AI matter a lot. The digital in-memory computing architecture is not just on paper. We have actually demonstrated this in real silicon. D-Matrix has built 3 generations of silicon over the last 4 years. And we were the first to build a digital in-memory computing engine in 6-nanometer silicon that has shown some very promising energy efficiency numbers as high as 150 TOPS per watt. This is the core foundation around which the D-Matrix platform is built. The D-Matrix platform also is built using chiplets. So we, instead of building very large chips that can cost a lot of money, we build smaller chiplets that can be connected in a fabric. And the interconnect that is used to connect these chiplets is also being built by D-Matrix. And this is a very energy efficient, high bandwidth interconnect that is used to connect these chiplets. So we have been systematically building up our hardware and also the software over the last 4 years and are ready to launch our first product called Corsair into the market in 2024. This is a purpose-built solution for generative AI and large language models. And it is accompanied with a software stack that is truly open source and enterprise grade. Our vision is that an AI model can be trained on any GPU and can be seamlessly ported onto the D-Matrix software stack for ingestion and then run in an extremely efficient fashion on the D-Matrix solution. The D-Matrix advantage, as I stated earlier, is around circuits, which is the digital in-memory compute portion. The numerics, we have come up with a numerical format called block floating point, which is extremely efficient for inference and has recently been backed by something called the MX Alliance that was announced at Open Compute a few months ago, which also stated that the block floating point numerical format could be very efficient for inference. Large companies like Microsoft, NVIDIA, Qualcomm, AMD are all supporters of the MX Alliance. We talked about chiplets, how we have built smaller chiplets that can be connected in a fabric with advanced packaging that allow us to be very flexible and modular on how we package our solution together. And finally, the open source software that accompanies all these hardware innovations. And the software is truly performant, scalable, and very easy to use. And that is our vision, that when you put this all together, it is truly a very unique recipe that offers much better throughput, latency, and total cost of ownership, making generative AI commercially viable for everyone. Here is a demo of what ChatGPT would look like running on D-Matrix versus a GPU on the right-hand side. The D-Matrix solution is able to run through a request very rapidly, really improving user experience substantially, as opposed to a GPU that is not as efficient and may take longer. This user experience does matters to users as more tools and more users start using generative AI. So what comes next? Please come build with us. we request everyone who is interested in joining our journey to reach out to us at the show. We are a group of leading technologists and value creators. This is a team that has built businesses over $1 billion in revenue in the past and have delivered over 100 million chips in production. We are a team of 100 plus people and have raised over 160 million in capital from marquee names like Microsoft, Temasek, which is Singapore's sovereign fund, Playground Global, which is a Silicon Valley venture firm, and other corporate sponsors. And we have a broad syndicate of global investors that are backing us. This is a snapshot of our journey. We started the company in 2019. We've been building the company for the last almost 5 years now. We have design centers in Sydney, Australia. Obviously, very excited to have opened our design center in India in 2022. And we also recently opened a design center in Toronto, and we are growing. We are continuing to grow. We expect to hire almost 30 to 40% more team members this year over the team members that we have. So we are rapidly scaling, and we encourage anyone who is interested to reach out to D-Matrix representatives at the show. We are super excited to be launching our product Corsair into the market in 2024. So it is a very exciting time to join D-Matrix, and we welcome your interest. With that, I would like to wrap up my keynote. Thank you, everyone, for listening to this opening keynote. And I really hope everyone has a wonderful rest of the show. Thank you.